Curve I have taken at the maximum value of the function. If you draw a line, that will be exactly parallel to the x-axis. It is tangent to the curve and parallel to the x-axis. Take 9 common factor, we get x square minus 2x minus 3 is equal to 0. So 9 cannot be equal to 0. So therefore I can equate the equation x square minus 2x minus 3 is equal to 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study one of the other important application of derivative, that is maxima and minima. That is when the function may attain its maximum value, when a function may attain its minimum value. Let's see it now. So here we have a local maxima, or it is called as relative maxima. You can see a curve here. So here is a point where the curve is attaining the maximum point, and here I have taken other points, that is neighborhood of the points m and n. You can see this is the point where the curve attains the maximum value at a point A, and this I have taken as a minus h and a plus h. A curve or a function is said to be attain a maximum value whenever there exists an interval, that is a minus h comma a plus h, such that f of a is greater than f of a minus h and f of a is greater than f of a plus h. We call that point as local maxima. So therefore, a curve is said to attain a local maxima at a point A where there exists an interval a minus h comma a plus h, which are the neighborhood of the points A. Then f of a is greater than f of a minus h, f of a is also greater than f of a plus h. Since this will be the maximum value, it is called as the point of local maxima. Next we have local minima or relative minima. So here is a curve which I have taken. You can see at point B, the curve is attaining the minimum value. Why it is called so? Because at this point, we can see the curve has the minimum value. If you observe the neighborhood points m and n here, so at point B, the value of the curve is minimum comparatively to point M and point N. So we say a curve is said to have its minimum value at that point when there exists an interval b minus h comma b plus h, such that so the function f of b is less than f of b minus h and f of b is also less than f of b plus h. So the functional value of the interval is always greater than the functional value of b. So that is f of b will be less than the b minus h and b plus h value. Hence we say the function attains its minimum value and the point is called as the point of local minima. So now we are restricting towards only the interval. Let's see what will be the value for the maximum for a function. It is called as maxima. A function y is equal to f of x is said to have a maximum at a point x is equal to a where there exists an open interval in the form a minus h a plus h, such that f of x is always less than or equal to f of a for all the values of x belongs to the interval a minus h to a plus h. Then f of x is maximum value of the given function. So here is a curve I have taken at the maximum value of the function. If you draw a line, that will be exactly parallel to the x-axis. It is tangent to the curve and parallel to the x-axis. So at the point of maxima where the function will attain the maximum value, the curve has a tangent which is parallel to x-axis. So therefore here you can see from the figure it is clear at point A the tangent is parallel to x-axis. Whenever we say the tangent, that means the derivative is 0, which is nothing but the slope. So therefore slope is equal to 0. That means dy by dx of a function is 0. So what is dy by dx as a function? We have restricted to an interval, that is at x is equal to a minus h, f dash of x must be greater than 0, and at x is equal to a plus h, f dash of x greater than 0. Hence we say f of x is maximum at a point x is equal to a, as you observe in the figure. So therefore f dash of x changes sign from positive to negative. So therefore you can clearly see that the value at x is equal to a minus h, here f dash of x is greater than 0, and the value you can observe at a plus h is greater than 0 again. So therefore here the sign changes from positive to negative. So therefore we can say at the point of maxima the tangent is parallel to the x-axis. Next we have minima. A function y is equal to f of x is said to have a minimum value at a point b. If there exists an open interval b minus h, b plus h such that the functional value is greater than f of a for all the values of x belongs to the interval b minus h, b plus h, then we say the function at the point b, that is f of b, is said to have a minimum value. So here is a curve which I have taken. You can clearly see at the point of minima, if you draw a tangent, it will be exactly parallel to x-axis again. So from the figure you can see clearly at the point B, the tangent is parallel to x-axis. So parallel to x-axis means the derivative of a function is 0. That is slope is 0. So therefore dy by dx is 0. So clearly again you can see f dash of x will be less than 0 comparatively to the function. Hence we say at point B the function has the minimum value and point B is called as the local minima or minima. Next we come across how to find the minima or maxima of a given function. So here are the steps which define to find out the way to find the maxima or minima of a given function. Let's see it now. Working method for finding maxima or minima. So any function will be in the form of y is equal to f of x or in terms of x and y separately. So step 1 is to find out dy by dx, that is f dash of x. Step 2 is to put dy by dx is equal to 0. Why to put dy by dx is equal to 0? Because at the minima and maxima of a function, the slope of a function is 0. That is, it is tangent to parallel to x-axis. Hence, we should substitute dy by dx is equal to 0. So, by substituting this, we can find the solution for the equation which will be in terms of x. So, therefore, we will get x is equal to a, x is equal to b, some numericals, etc. That is, we are going to find the value of x. Next, we have to derive the given function again. We have to find the second order derivative. So, by looking at the second order derivative, if the derivative is positive, that means the function is minimum. Remember, if it is positive, it is minimum. If the derivative is negative, it is maximum. So, if at x is equal to some point a, if the derivative of the function is 0, then we say it is neither minima nor maxima. So, therefore, x is equal to a at this point is called as point of inflection. So, remember, if it is positive, we say it is minimum. If it is negative, we say it maximum. And at x is equal to a, if the derivative is equal to 0, that means it doesn't have any maxima or minima. It is said to be a point of inflection. Next, step 4. Here, after finding whether the given function have maximum value or minimum value through d square y by dx square, later using the point x, that is which we have already solved, substitute the value of x in the given equation and find y maximum or y minimum. So, find dy by dx, put dy by dx is equal to 0, find d square y by dx square, check whether it is maximum or minimum, use the values, substitute it back to find out the value of y, then see whether it is a maximum value or a minimum value. Let's look at the problems now. First problem, find the maximum and minimum value of x cube minus 9x square plus 15x minus 1. Step 1 says, so first write this function in the form of y is equal to x cube minus 9x square plus 15x minus 1. So let's find dy by dx. So dy by dx is equal to 3x square minus 9 into 2x plus 15. So this implies dy by dx is equal to 3x square minus 18x plus 15. Next step is put dy by dx is equal to 0. So substitute dy by dx means 3x square minus 18x plus 15 is equal to 0. Now take 3 as a common factor, we get x square minus 6x plus 5 is equal to 0. Since 3 cannot be equal to 0, I can equate x square minus 6x plus 5 is equal to 0. So solving this, we get x square minus 5x minus x plus 5 is equal to 0. We get the factors as x minus 5, x minus 1 is equal to 0. So this implies the value of x is equal to 5 or x is equal to 1. Now we got two different points here. So let's find the second order derivative, that is d square y by dx square. So take this equation as 1 now. So derive it again, you will get the second order derivative. So it is 3 into x square, which is 3 into 2x minus 18. So therefore, d square y by dx square is equal to 6x minus 18. Now we have 6x minus 18. Find the value of d square y by dx square at point x is equal to 1 and at point x is equal to 5. So at x is equal to 1, d square y by dx square is equal to 6 into 1 minus 18, which is equal to minus 12. So here it is negative, that means less than 0. So therefore, f of x has maximum value at x is equal to 1. Now we got at x is equal to 1, the function have the maximum value. So let us substitute x is equal to 1 in the given equation. What was my given equation? That is x cube minus 9x square plus 15x minus 1. So therefore, the maximum value y max is equal to 1 cube minus 9 into 1 square plus 15 into 1 minus 1. Solve this. Y max is equal to, here you can cancel plus 1 minus 1, 15 minus 9, which is equal to 6. So this is the maximum value of the given function. Now let's check at x is equal to 5. So at x is equal to 5, d square y by dx square is 6 into 5 minus 18. So that is plus 12, which is greater than 0. So if it is greater than 0 means, so therefore f of x has minimum value at x is equal to 5. So therefore y minima or y minimum is equal to, so the same equation, x cube means 5 cube minus we have 9 into 5 square plus 15 into 5 minus 1. So solving this, so we have here 125, 225 plus 75 minus 1. So therefore, y minima is equal to minus 26. So clearly you observe that we have a function y is equal to x cube minus 9x square plus 15x minus 1. According to step 1, derive the given function. Steps 2 says put dy by dx is equal to 0 and find the values of x. Step 3 says find second order derivative and substitute the values of x in d square y by dx square and substitute the value in d square y by dx square. Find whether it is positive or negative. If it is less than 0, it has maximum value. Find the maximum value in the original equation. If it is greater than 0, that means it has a minimum value. Substitute the same thing in the given equation. Find the minimum value. So, therefore, for this function, 6 is the maximum value and minus 26 is the minimum value. Next question we have, find the maximum value of log x divided by x. So, we have given y is equal to log x by x. So, let's put dy by dx. So, this is in the form of u by v. What does u by v says? So, vu dash minus uv dash divided by v square. So, we have x into derivative of log x is 1 by x minus log x into derivative of x is 1 whole divided by x square. So, we get dy by dx is equal to 1 minus log x divided by x square. Take this as equation 1. Next step is put dy by dx is equal to 0. So, if you put this is equal to 0, this implies 1 minus log x by x square is equal to 0. 1 minus log x is equal to 0. Log x is equal to 1. So, this implies here, so when nothing is given here, the base is exponential. So, when you shift here, x is equal to e. So, we have x is equal to e now. So, let's see d square y by dx square now. So, we have dy by dx now. Again, first function, again 0 minus 1 by x minus 1 minus log x into 2x divided by x square whole square becomes x power 4. So, here d square y by dx square is equal to cancels. So, this is x minus multiply 2x and here minus, here plus 2x log x whole divided by x power 4. So, this is minus 3x d square y by dx square is equal to minus 3x by x power 4 becomes minus 3 by x cube plus x cube cancel 2 log x divided by x cube. Now, we have d square y by dx square. Substitute x is equal to e in the given d square y by dx square. So, at x is equal to e, d square y by dx square is equal to, you can see here it is minus 3 by e cube, minus 3 by e cube and 2 log e by x cube plus 2 log e by e cube. So, you can clearly observe log e to base e is always 1. So, this value takes 1. So, this is minus 3 by e plus 2 by e, which is minus 1 by e. Since you have a negative sign, it is clearly less than 0. That means the function is maximum. So, therefore, y has maximum value. So, therefore, y max is equal to, what is the given function? Log x by x, that is equal to log e by e. We know log e is 1. So, the value is 1 by e, or the maximum value of the function is 1 by e. Next, we have show that x power x is minimum at x is equal to 1 by e. Let's take y is equal to x power x. Apply log on both sides since this is in the form of powers. So, x log x. Differentiate it 1 by y into dy by dx is equal to first function into derivative of the second plus second function into derivative of the first. So, here I can write this as 1 by y dy by dx is equal to 1 plus log x. So let's take it as equation 1. Let's put dy by dx is equal to 0. Put dy by dx is equal to 0. So then we get it as 0 is equal to 1 plus log x, or log x is equal to minus 1. So therefore, if it is 1, we would write it as e power 1, which is nothing but e. So here it is x is equal to e power minus 1, which is equal to 1 by e. So therefore, the point is 1 by e. Now, let's take this function. So equation 1 implies, rearrange it, we have dy by dx is equal to y into 1 plus log x. Let us take the derivative again, that is to find out d square y by dx square. Find it. D square y by dx square is equal to, first function, derivative of 1 plus log x is 1 is 0, log x is 1 by x, plus 1 plus log x into dy by dx. So now we have dy by dx can be written as y into 1 plus log x. So d square y by dx square is equal to y by x plus 1 plus log x into y into 1 plus log x. So from the above observation, I can replace dy by dx as y into 1 plus log x. So the common factor is y. Therefore, d square y by dx square is equal to y into, so here you will get it as 1 by x plus 1 plus log x whole square. Now let's see at the point x is equal to 1 by e, because solving for x we got it as 1 by e. At x is equal to 1 by e, d square y by dx square. So here y can be replaced with x power x into 1 by x plus 1 plus log x whole square. So therefore d square y by dx square is 1 by e to the power 1 by e, and here it is 1 over 1 by e into 1 plus log 1 by e whole square. So by looking at this, we can clearly see it's a positive quantity, so which is greater than 0. So therefore, f of x has minimum value at x is equal to 1 by e. So no need to find out the minimum value. Here they have asked you, show that it is minimum at the point x is equal to 1 by e. So by substituting x is equal to 1 by e, we got d square y by dx square as a positive quantity. That means the function has a minimum value at the point x is equal to 1 by e. Next question. Find the maxima and minima of the function f of x is equal to 3x cube minus 9x square minus 27x plus 30. So let me take this as y. Let us find out dy by dx. So solving this, x cube is 3x square, 3 3s are 9x square. X square is 2x, 9 into 2x is 18x, and derivative of x is 1. So it is 27, derivative of 30 is 0. Next, put dy by dx is equal to 0. So we'll get 9x square minus 18x minus 27 is equal to 0. Take 9 common factor, we get x square minus 2x minus 3 is equal to 0. So 9 cannot be equal to 0. So therefore I can equate the equation x square minus 2x minus 3 is equal to 0. So I can write this as x square minus 3x plus x minus 3 is equal to 0. I'll get the factors as x minus 3, comma, x plus 1 is equal to 0. So therefore, this implies x is equal to 3 and x is equal to minus 1. The next condition is we need to find out d square y by dx square. So therefore, next d square y by dx square is equal to, we have 9x square is 2x, 9 2s are 18x minus differentiation of 18x is 18. Let us put the values of x At x is equal to 3, d square y by dx square. Solving this, 18 3s are 54 minus 18, which is equal to 36, greater than 0. If d square y by dx square is greater than 0, that means it has a minimum value. So this implies f of x has minima. So therefore, y minimum is equal to, substitute the value of x is equal to 3 at y, it becomes 3 into 3 cube minus 9 into 3 square minus 27 into 3 plus 30. So y minimum is equal to, solving this, we get the value as minus 51. So this is the minimum value of the given function at the point x is equal to 3. Let's see what happens at x is equal to minus 1. At x is equal to minus 1, d square y by dx square is equal to 18 minus 1 minus 18, which is minus 18 minus 18 minus 36 less than 0. So therefore, f of x has maxima. If it is less than 0, that means it contains a maximum value. So therefore, y max is equal to, look at the equation what we have, 3 into x cube, that means 3 into minus 1 whole cube minus 9 minus 1 whole square minus 27 minus 1 plus 30. So therefore, y maxima is equal to, on solving this, we'll get the value as 45. So 45 is the maximum value of the given function at the point x is equal to minus 1. Next question we have, divide the number 40 into 2 parts such that their product is maximum. So we have to divide the number into 2 parts where their product is maximum. Let us take, we have two numbers, x plus y is equal to 40. So what I can write, y is equal to 40 minus x. Now what they have given, their product is maximum. If their product is maximum means their second order derivative must be less than 0. So let p is equal to x into y. We have got y as 40 minus x. So therefore here I will get x into 40 minus x. So therefore p is equal to 40x minus x square. Let's see the first derivative, that is dp by dx is equal to, here you will get 40 minus 2x. Let's see d square p by dx square now. So d square by dx square, if you take, for the first one it is 0, minus 2 less than 0. Therefore, it has maximum value. That means, according to the given condition, the product is maximum value. So therefore, it has a maximum. Now, put dp by dx is equal to 0. So that is 40 minus 2x is equal to 0. This implies 2x is equal to 40. Therefore, x is equal to 20. So we got 1x is equal to 20. Now what is y? This implies y is equal to 40 minus 20 is equal to 20. So therefore, what are the numbers? The numbers are x is equal to 20 and y is equal to 20. So clearly you can see the sum is 40 and the product is maximum. Next question. Show that f of x is equal to 4x power 5 minus 25x power 4 plus 40x cube minus 3 has a point of inflection at x is equal to 0. If you want to get point of inflection, that means its second order derivative must be 0. Let's take it, y is equal to 4x power 5 minus 25x power 4 plus 40x cube minus 3. Let us take the first order derivative, that is dy by dx. it becomes 4 into 5x square, that is 20x power 4 minus 25 fours are 100x cube plus 120x square 0. Now we have to show that x is equal to 0 is a point of inflection. So therefore, first put dy by dx is equal to 0. So if you put dy by dx is equal to 0, we get 20x power 4 minus 100x cube plus 120x square is equal to 0. So looking at the equation, we can take 20x square as a common factor. If you take 20x square, you will get x square minus 5x plus 6 is equal to 0. So solving this also we get the factors. So here we can write it as 20x square into x minus 2, x minus 3 is equal to 0. So if you substitute the values as 0 here, we get x is equal to 0, x is equal to 2 and x is equal to 3. So these are the points, required critical points for the given equation. Now let's see whether at x is equal to 0 is a point of inflection. So let's find out d square y by dx square. So you have dy by dx, let's differentiate it again. We have 80x cube minus 300x square plus 240x. At x is equal to 0, clearly you can see d square y by dx square is equal to 0. So 0, 0, 0. So therefore, what we can say, the function has a point of inflection at x is equal to 0. So if we have d square y by dx square is equal to 0, that means f of x has neither minima nor maxima at x is equal to 0. So therefore, f of x has point of inflection at x is equal to 0. Next question, find the maximum and minimum value of the following function. The same, first put y is equal to x cube minus 3x, put dy by dx is equal to 3x square minus 3, put dy by dx is equal to 0. So this implies 3x square minus 3 is equal to 0. This implies x square minus 1 is equal to 0. This implies x is equal to plus or minus 1. So let's find d square y by dx square. Now d square y by dx square is equal to 6x. Now at x is equal to 1, d square y by dx square is equal to 6 greater than 0. So therefore, f of x has minima. So this implies y minimum is equal to, put x is equal to 1 here, that is 1 minus 3x is equal to, if you put x is equal to 1 here, you will get minus 2. So this is the minimum value. Now at x is equal to minus 1, d square y by dx square is equal to minus 6, which is less than 0. This implies f of x has maxima. So therefore, y maximum is equal to 1 minus of minus 1, that is into 3, which becomes plus 3, 4. So this is the maximum value of the given function and minus 2 is the minimum value of the given function. So therefore, y maximum is equal to minus 1 whole cube minus 3 of minus 1, which becomes minus 1 plus 3 is equal to 2. So this is the maximum value of the given function. Let's look at the second one, 2x cube minus 3x square minus 36x plus 10. So here we have dy by dx is equal to 3 2s are 6x square minus 6x minus 36. Put dy by dx is equal to 0. This means 6x square minus 6x minus 36 is equal to 0. Take 6 as a common factor. You will get x square minus x minus 6 is equal to 0. 6 cannot be equal to 0. This implies x square minus x minus 6 is equal to 0. So here clearly you can observe x square minus 3x plus 2x minus 6 is equal to 0. You can take x minus 3 and x plus 2 as a factors. Therefore, you will get x is equal to 3 and x is equal to minus 2. Let's see the second order derivative. D square y by dx square, that is equal to, if this is dy by dx, it is 12x minus 6. Now, at x is equal to 3, d square y by dx square is equal to 12 3s are 36 minus 30. So, you will get greater than 0. This implies f of x has minima. So, therefore, y minimum is equal to, put x is equal to 3 in the given equation, 2 into 3 cube minus 3 into 3 square minus 36 into 3 plus 10. So, therefore, y minimum is equal to, solving this equation, we will get the value as 37. So, this is the minimum value of the given function. Let's see the maximum value, that is at x is equal to minus 2, d square y by dx square is equal to minus 24 minus 6, which is equal to minus 30. So, less than 0. So, this implies f of x has maximum. So, therefore, y maximum is equal to, you can see the equation 2 into x cube, that is 2 into minus 2 whole cube. Next, we have minus 3x square minus 3 into minus 2 whole square. Next, we have minus 36x minus 36 into minus 2 plus 10. So, therefore, y maximum is equal to 38. So, solving this, you will get the answer as 38. So, this is the maximum value of the given function. Next, we have the sum of two natural number is 48. Find the numbers when their product is maximum. So, let's take sum of two natural numbers, x plus y is equal to 48. So, this implies y is equal to 48 minus x. Now, they have given their product is maximum. Let me take the product as x into y. So, which is x into 48 minus x, that is equal to 48x minus x square. So, given their product is maximum. So, therefore, let's see now. Let's derive dp by dx. We get it as 48 minus 2x. So, put dp by dx is equal to 0. Let's see the derivative d square p by dx square. So, if you derive it, you will get the value as minus 2 less than 0. So, therefore, f of x has maximum. So, according to the given condition, their product is maximum. Now, put dp by dx is equal to 0. We get 48 minus 2x is equal to 0. This implies 2x is equal to 48. Therefore, x is equal to 24. So, we got x is equal to 24. Let's find out y. Now, y is equal to 48 minus x, which is 48 minus 24, which is equal to 24. So, therefore, the numbers are x is equal to 24 and y is equal to 24. So, this is the given solution. Let's look at the next question. Find two positive number whose sum is 14 and the sum of the square is minimum. So minimum means the second order derivative must have a positive quantity. Let's see now. Two positive number. Let me take it as x plus y is equal to 14. So this implies y is equal to 14 minus x. The sum of the squares. So let's take x square plus y square. So let p is equal to x square plus y square means p is equal to x square plus 14 minus x whole square. Expand this x square. So 14 square is 196. So plus x square minus 14 twos are 28x. So therefore p is equal to 2x square minus 28x plus 196. Now let's derive this with respect to x. So dp by dx is equal to 4x minus 28. Let's see whether we have a minimum or not. Let's derive it again. D square p by dx square. The answer is 4, which is greater than 0. Therefore, f of x has minima. So now let dp by dx is equal to 0. That is 4x minus 28 is equal to 0. This implies x is equal to 4 sevens. So x is equal to 7. Now we have y is equal to 14 minus x, which is 14 minus 7. So therefore we got y is equal to 7. So therefore the numbers are 7 and 7. So this is how we can find the sum of any two numbers whose square has a minimum value. So in this session, we have found how to find a maximum or a minimum value at a given point for a function with the help of derivatives. In the next session, we'll continue one more application that is in the field of commerce of derivatives. Until then, keep watching, keep learning and keep exploring. Thank you.